Hello mathematicians, and ready for your lesson today in geometry. We are starting chapter 5 and we're doing lesson 1 today, and we're going to be talking about angles of triangles. Some of this you guys already have a background information of, so I am going to scoot through kind of few fast, and other stuff I'll take a little bit longer to go through because we'll have a couple new theorems. All right, so triangle classification. So we will ask you to start classifying triangles either by their sides or by angles. And sometimes we'll ask you to do both. So make sure that you are reading your directions. So if they're asking for just sides, just angles, or sometimes they ask for both. So please make sure you're reading your directions. So how do you classify an angle by sides? And when I say sides, you guys should already be thinking, are there 0 sides congruent, 2 sides congruent, or all 3? So just very quickly, we're either going to have an equilateral triangle, or if 2 sides are congruent, we call that isosceles. Or if no sides are congruent, we call that scalene. Okay, that's sides. Then if we go by angles, we either have acute, obtuse, right, and there's one more. Do you guys remember the one more? Straight. Okay, all right. So, classifying by sides, equilateral has 3 congruent sides. Now, I don't know why for isosceles they say at least congruent 2 at congruent sides. So, if you have one, you always want to give it the best name you can. So, if you for sure know all 3 sides are congruent, you are going to say equilateral. But they're going to trip you up and catch you up and say, are all isosceles triangles equilateral? True or false? And that is false. But what if they say, are all equilateral triangles isosceles? And then you would say true because it has at least 2 congruent sides. So please make sure you are paying attention to that definition. And isosceles is at least 2 congruent sides. Scalene means no sides are congruent. So if we're looking at this triangle, we're looking at ABC. So A, B, C. So now what would we say? Well, they're telling us this side is congruent to that side. And because they only have 2 congruent marks, a lot of times we just jump to the fact and we say, oh, that's 2, that's isosceles. But in the fact here that they're saying this side and this side are congruent, that means this side is also 15. So all 3 of them are 15. So the best name here would be equilateral. And then if we jump to the triangle ABD, ABD, we've got a 15, an 18, and ooh, what did I go over? Was that a 5? So then this is 20. None of the sides are congruent, so we're going to say scalene. All right, by its angle measure. So acute, 3 angles are acute. All 3 of them are less than 90 degrees. Equiangular, that means all of them are going to be the same measurement. So what would each measurement be? And we'd take 180 divide by 3, so that is 60 degrees. Right triangle, 1 angle is right, and obtuse, 1 angle is greater than 180 degrees. All right, classify each triangle by its measures. Oh, I think on that first screen, did I say straight? So if triangle, it's certainly not going to be a triangle. I was thinking of angles there. Sorry about that. So we're not going to have a straight because we were talking about triangles. My brain was thinking about angles. Sorry about that for confusing you guys there for a second. All right, so classifying by its angle measurement, EHG. EHG, looks like we have a right angle in there, so we're going to call that a right triangle. EFH, EFH. So we have a 30, 30, this is 60, this is a linear pair, so that leaves this to be 120. That one angle is bigger than 90 degrees. So we're going to say it's obtuse. All right, explain what process you would use to classify triangle PQO. So we're going to classify it by its sides here and by its angles. So we would find the length of all three sides. And personally, what I would do to find the lengths of all three sides, because this is on a grid, you can use your distance formula. But you could also say that this is a right triangle here. So this is 1 and this is 2. So to find the length of PO, what I would just use is my Pythagorean theorem. So I'd say 1 squared plus 2 squared and take the square root of that. So 1 squared plus 2 squared, are we going to end up with the square root of 5? And then just grab your calculator and take the square root of 5. And what's that? 2.23? And OQ. So if we do OQ, this length right here is 6. This length is 3. So OQ, I would do 6 squared plus 3 squared and take the square root. So what's that? 36 plus 9. So what do we have? The square root of 45. And if we take the square root of 45, that's going to be 6.7. And then the last one, we've got 1 squared plus, what is that? 7 squareds, because we have 6, 7. 1, 2, 3, 4, 5, 6, 7. So we're going to do 1 squared plus 7 squared and take the square root. So 49. So we have the square root of 50. And the square root of 50 comes out to be 7.1. So they're all different. So we would say that this is scalene. Then if we find the slope of PQ, so PQ is up 1 over 7. OQ is going to be, so what's that up? 1, 2, 3 over 6. So, whoops, that's a 6. So that is 1/2. And PO is going to be up 2 over 1, so that's a -2. Well, if we look at 1/2 and -2, they are perpendicular to each other, so we would say right. Okay, so if we're going to be classifying triangles, we want to find out lengths of sides, and then you want to check to see if anything's perpendicular or not. All right, how do you draw an exterior angle on a polygon? So to draw an exterior angle, it must be a linear pair with an angle on the inside. So a linear pair. So this would be an angle, this would be your exterior angle. It must form a linear pair. Now, we could also draw this line and just extend it, and we could say 3, and we could have 4. So it needs to make a linear pair with an angle on the inside. So 1 and 3 make a linear pair, so 3 could be considered an exterior angle. 1 and 2 make a linear pair, so 2 could be considered an exterior angle, but 4 is not, because it does not make a linear pair. This one actually is vertical. Okay. So angles 1, 2, and 3 are all interior angles. 6, 4, and 5 are exterior. Now, we could also put 8 and 9 in here. 8 is exterior because it's a linear pair with 3, but 9 is not. Okay, right now, if you do have a protractor, I would want you to take this out. So this is my first time giving this a try here, and we'll see if I can get this to work. But I want us to measure this angle in here. So I'm going to measure this angle, and I'm going to start at 0 and go up. So it looks like my angle 1 is going to be 50 degrees. So angle 1 is 50 degrees. All right, then I want to kind of rotate this around. Might take me a couple chances here. Let's see how close I can get that. Slide it over here, and I'm going to measure angle 2. And if I go up to angle 2, 10, it looks like that is about 80 degrees. So let's see here. Angle 2 is 80 degrees, and then I want to measure this exterior, measure this exterior angle over here at 4. So if I measure this exterior angle over here at 4, looks like that is 130 degrees. So angle 4 is 130 degrees. So is there any kind of conjecture or thing that you can figure out to find out from this exterior angle right here, this exterior angle 4, and then we call these two over here the two remote interiors. So not the interior angle that makes the linear pair with that exterior, so not 3. The remote interiors would be the two interior angles that are furthest away from that exterior angle. And what did we find out? The sum of the two remote interior angles equals that exterior angle. So this is a theorem that we will be using in this section. So you guys should already know this from previous. The sum of the interior angles is 180 degrees. That should be something you guys already know. All right, this is something that kids don't use very often, but I'm sure it is pretty logical that if we have a right triangle, all 3 angles add up to 180, but if we subtract out that 90-degree angle, that means the 2 acute angles will always add up to 90 degrees. So the acute angles of a right triangle are always complementary. And then the one I just talked about. So you might want to freeze this, copy this down, but the measure of the exterior angle is equal to the sum of the 2 remote interior angles. All right, so let's give this a try. How do we find the measure of angle 1? We have an exterior angle and the 2 remote. So if we take 40 plus 3x, that must be equal to the measurement of that exterior angle. So if I add 10 to both sides, I get 50. Subtract 3x, so I end up with 2x. So it looks like x is going to be 25. So angle 1, to find the measure of angle 1, I can put 5 times 25 and then subtract 10. So 5 times 25 is 125 minus 10. So that means this angle is 115, and that is a linear pair. So I take 180 minus 115, and that should be the measure of angle 1. So 180 minus 115 leaves us with a 65-degree angle. All right, in the second example that we have going on here, a lot of you are going to set this up equal to 180. You're going to say 90 plus 2x plus x minus 6 equals 180. So a lot of you are just going to go 90. And then you're going to have plus 2x plus x minus 6 equals 180. But now, if we subtract 90 from both sides, it brings us to that theorem that we were talking about. So that 2x plus x minus 6 equals 90. So this is the theorem that they're trying to get us to use. The 2 acute angles in a right triangle always add up to 90 degrees. So we have 3x, and make sure that you add 6, so we get 96, and 96 divided by 3. So x is 32, but what do they really want to know? The measure of each acute angle. So this acute angle up here is going to be 2 times 32, so we have 64 degrees. And then if we do 32 minus 6, we end up with 26 degrees. Now, notice this angle and this angle together are complementary. All right, that should bring us to the end of this lesson. So, good luck on your homework.